now we need to go to the remote server part, that is github.com. So the first thing that you need to do is you need to just type github.com and you will come here, and this is basically the site for GitHub. So let's suppose I want to sign up, then I can click on this button, sign up for GitHub, or else I can click here as well. And if I already have an account, then I can just click on sign in and I can proceed further. So now what happens here is I can just click on sign up. So it is telling welcome to GitHub. Let's begin the adventure. This has changed a lot since the last time I've used, and I haven't created a account since a very long time. So it's a good thing that I am also doing this along with you. And if you're doing it, do it with me. I'll go slow, don't worry. So for that, I need to enter my email ID. So I'll enter my email ID as boxitupsam@pythoholic.com. So this is my website or email address, not website, sorry, email address, and I'll just click on continue. I'll just create a password. I'll create a strong password. So once I have filled in the password, I'll just click on continue. So now I have entered the password. The password looks strong. Make sure it is at least 15 characters or at least 8 characters, including a number and a lowercase letter. Click on continue. Enter the username. I can just type Pythoholic because I already have a account with the username Pythoholic, so it's not allowing me to create the same one again. So you have to add a unique name to this. Pythoholic-demo is my username. I'll just type Pythoholic demo and I'll click on continue. Would you like to receive product updates and announcements via email? No. And please click or please solve this puzzle to verify that you are a human. Let's start puzzle. Pick the spiral galaxy. So among all these things, all these images, this one is the one. So I'll just click on this and again, and I'll just click on create account. So what did we do? We entered the email address. We entered a strong password. Please save the password or else you will not be able to log in. You have to just do forget password and create a new password again. So make sure that you store it securely somewhere. Add a username and then just create the account. And once you have created the account, it will send a verification code to your email address. And once you get the verification code, you can just enter it. It'll immediately send you the verification code, so don't worry about it. So I'll just collect my verification code and I'll enter it. So once I've entered the verification code, it takes me to this page. Welcome to GitHub. You have successfully created your GitHub account and we are glad you're here. So I'll just choose just me and a student and I'll just click on continue. Now I'll just click on continue. See additional students benefit also. It is coming the same way, GitHub Pro, but we don't want GitHub Pro right now. So just click on continue for free. Wow. This is just amazing, isn't it? Home for all developers, including you. See, this is basically your dashboard. This is where you can create your own repositories, new repositories. You can include your personalized profile in the README file. And here you have some of the advertisements for GitHub Copilot. I'll just close this and this as well. We don't need this right now. And the latest changes made to the GitHub source. So everything that you want is placed here. So now we have created our GitHub account. So the first thing that you need to do is go to your profile. So here, there's the profile. You can add status. You can edit your profile. You can add a profile picture as well. All your contributions will be shown here, like how many contributions you have made. And yes, you joined GitHub on October 19, 2020. So this is showing you the timeline. And if you click on repositories, we don't have any public repositories yet. We haven't created a project. So the first thing that for us would be to work on GitHub, but before that we need to go to Git and we need to create our own new repository, and then we'll see how we can actually communicate between the local repo and the GitHub repository that we have here. Now let's come back to GitHub, and this is where we would want our local repositories to be a part of the remote repository, so that everyone who wants to make use of it can make use of them and can clone them, and they can add their functionalities or code or anything that they want, like not anything that they want, but basically the changes that they want to do, and they can also commit to this particular repository. So that this is the part where we wanted to solve the sharing problem or sharing part of the problem that we had. So Sam was working as a developer independently in his local machine, but later on he moved into Git, where he was able to commit the changes locally, but he wanted a solution where he could share the repository for other teammates to make use of. The most important thing for us is to add the repository that we had locally to remote. So the first thing here, if you are working on GitHub, to basically create the repository. But for now, what I would do is this is the OG one that I wanted to tell you, because this is how I used to create. And okay, not to get too emotional here, let's click on new repository. For the simplicity that I have, I would want to keep it simple, and I won't want to have the repository name that we had previously and here as well. So I want to keep it constant. So website demo. Okay, so website demo is available to us, and great repository names are short and memorable. Need inspiration? How about sturdy umbrella? So here what happens is, if I want to, I can give it this way as well. So this is, if suppose GitHub tells you that this is a very good way to name the repository, then it is also fine. You can just type website demo, and this is a sample YouTube demo for GitHub repository. Fine, this is simple. I'll keep this public right now because there are some features that are not available with private that I'll tell you later. But for now, I'll just keep it public so that anyone, if they want to use it, they can use it. I don't want to add a README file because we already have it. And that's it. And here I would just click on create repository. So now that you have created the repository, where is the code? How will we import the code here? Don't worry, we will do that, because there are 3 options available to you. So once you have created the repository, this is the quick setup page, and you can as well clone this repository, add your files and then upload them. That is one option. Or you can create a new repository in your command line like we did, or else you can push an existing repository from the command line. So for that, what we need to do is we need to use these 3 commands to basically push our code into this remote repository. So first thing that we have to do is we have to just copy this git remote add origin, because I want to make this as an origin. So for anyone who wants to make use of this code, they can use it from this particular repository. So this is my origin. So if I have to clone as well, I can use this as a clone URL. Here, if you can see, this is the clone HTTPS URL. I can just clone this repository also. But for now, I'll add it as a remote. So for me, the remote is this particular entry point or endpoint. This is my remote. So for Git to understand what is the origin or what is the remote endpoint, I have to basically add that. So now what happens here is I'll just minimize this and I'll go back. So there's the repository that we have. Let's do a CLS here, and we will do a git remote add origin. We have added it, but to view what exactly are the features available with this particular origin, you can just type git remote -v, and it'll tell you we have 2 options for fetch and push. So fetch is basically pull and push is basically push. So don't worry. So these are the two origins. So this was our first step to add the remote add option, or git remote add origin. Now if I go back, the second one was git branch -m main. But if you can see, this repository does not have any branches yet, but it is telling me that I can actually push things into the main branch, or the name or the branch that is named main. But for me, I am more comfortable with having my main branch named as master. So what I can do, I can just change this to master, because I am currently working on the master branch and I don't want to confuse myself going onto the GitHub and I'm seeing there that there is no master and there is a main branch there. I don't want that. I want to keep it consistent. So git branch -m master, and I'll just hit enter. Okay, 1 minute. I'll just tell you. I'll just make this as an origin. Now push -u. I'm just going to push and make this as a part of the origin. Origin means in the remote. Now it will be updating all the code that I have. So git push command helps us to push all the changes that we have locally to the remote repository. And that is why, if you see, it is pushing or writing objects to the remote, to https github.com pytholic demo website demo.git. This is the URL, remote URL. And the new branch that we have created is master, from master, and branch master set to track origin /master. Now, if you do a git branch here, 1 minute. All, yes. That's what I was thinking. Where did the remote go? So now you will see a remote /origin /master. So on remote, the origin master is this particular branch. Now you have to just come here and refresh the code, refresh the website. Now you can see we have the changes that we had in our local are added to our remote as well. So that's a very good thing, isn't it? We have added the code that we have on our local repository, and we have made a connection to the remote, and we have added our changes. That is a very good thing. But if you want to see here, there is only one branch. If you go and view all the branches, there will be no branches here, because there are no remote origins created for that particular branch. Even though you go back and see, like there are 3 branches here, but there are only one branch mentioned because there are no remote origins for the other 3 branches. Now what happens here is, so now this is done. Let's suppose this is the simple way for us to upload or push the changes to the remote server. What I want to do is, let's suppose I just close this, and this is the the folder structure that I was working on, isn't it? Let me just keep it here. So this was the file that the folder that I was working on. This is my repository. I'll delete this. I don't want this. So now accidentally I deleted it. I don't know what to do now, but I know that there is a remote repository from where I can clone this particular repo that I had, and I won't lose my source code. So that's a very good thing. Now in front of you, I have deleted it. I don't have any entries for that, but I have a remote server that can help me. So how to do that? Let's go back. I can actually clone this, but for now what I'll do is I'll just do a git clone. I'll copy this URL, the endpoint, and here what I can do is I'll go to desktop and I will perform a git clone operation. Git space clone. Git clone actually creates a clone of the repository from the remote onto the local, and just hit enter. Okay, congratulations. We haven't lost the code that we had. Now we have website demo with us. So let's move inside that particular repository. What is the first thing that we do? We do a git status. Okay. On branch master, your branch is up to date with origin /master. So that is why it is trying to refer it to the remote branch, origin /master. And it is telling you that the changes are good and you have your changes intact. So let's see. Git log. Okay. So this was the last commit that we had made, new changes to develop, which we had committed to the master branch. So everything that we wanted to, have is available to us because we had a remote repository that saved us. And now even if I don't have anything on my local, I can still clone the repository. And that is how, let's suppose I am one of his teammates, I am one of the Sam's teammates, I can also download the code. And the next big part was for me to update my changes. Let's suppose I am Sam's friend or I am Sam's teammate and I want to make some changes to this repository. So I don't want to make changes to this particular main branch, isn't it? This is the master branch. So what I can do is I can create a branch from here. Git branch develop, and I'll do a git branch. Okay, do a CLS, do a git branch -- all. Now what happens is the remote origin head is origin/master, and I am in master. So I will do a git checkout develop. Now I have switched into master, develop, sorry. I have switched to the branch develop right now, and git branch -- all. I'll show you that, yeah, I'm not telling you any lies. That has switched to develop, so I'm in develop right now. So let's make some changes. This is develop branch code. Okay. So this is the change that I wanted to make. So that is the change that I wanted to make. Now what happens here is you have to do a git status. So this is the modified change. Let's do a git commit -am so that we can add and append the message at the same time. New changes to develop. Sorry, I had already given this. New remote branch testing. Let's suppose this is my message. Okay, everything is set. Let's hit enter. Now we have added the change to develop branch. What if I want to push the changes from the develop branch to the remote repository? So the most important thing that you would say is, okay, let's do a git push. Let's see. So I am in git develop branch itself. I'm not lying. So let's do a git push. Okay. Fatal. The current branch develop has no upstream branch because there is no reference. There is no reference, isn't it? On your remote, there is no branch called develop. So to which branch is going to store your changes? It'll be confused, isn't it? So in order to commit our changes to that particular branch that is develop, we have to push the current branch and set the remote as upstream. So we have to make develop as our current upstream. So copy this git push -- set upstream. We are setting the upstream. We are setting the path for the develop branch to be created. So I have written git push -- set upstream origin develop. Okay. So now it has been pushed. New branch that has been created is develop, and branch develop is set to track origin/develop. Now let's go back. You can see here develop had recent pushes less than a minute ago. You can create and compare a pull request. Sorry, compare and create a pull request as well. So here we can see there are two branches. So just click on this. Now this is your branch that you're working on, that is develop. Active branch is also develop. Default branch is master. Now let's go back. In normal scenarios, if you go to settings for this particular project, you have branch, and every branch should have some protection rules. Like you can define branch protection rules to disable force pushing, prevent branches from being deleted, and optionally require status checks before merging. But the problem here is I'm working individually on this particular branch. So if suppose I had another user who was actually working on this, then I could have added them. I'll do that later on. But for now, I just want to show you, you can add rules as well to protect this branch, master branch, so that no one can make changes or push changes without any pull request. Pull request is a way for us to verify the changes, that the changes are good and they are ready to be merged into any branch that you want to have. But mostly it is good that you have a strong protection rule to encounter any such force pushing, deletion of branches, all these scenarios. You should avoid them for the master branch. So let's click on add rule. Here the most important one is require a pull request before merging. So I can just click on this, and once you have selected this, require a pull request before merging, this is very good. You can actually select git require approval, and you can select the number of approvers that should basically approve this pull request before it can be merged. Before that, it cannot be merged. Let's suppose you have a developer, you have a manager, you have a senior engineer, and you have given them the approval request, and before they approve it, you will not be able to merge it. So the required number of approvals, let's suppose that is 3, then there should be 3 approvals for us before merging it. Otherwise it will not show the option only to merge. And by default it is 1, the minimum is 1 and the maximum is 6. I'll just uncheck this. Dismiss tail pull request approval when new commits are pushed. These are something that are very requirement dependent. If you have that requirement, you can use them, but this is very important. Require a pull request before merging. And you can also lock the branch, which makes the branch read only. Users cannot push to this branch, so this can only be read. And here requires deployments to be succeeded before merging. So choose which environment must be successfully deployed before branches can be merged into a branch that matches this rule. So if you select this, no development environment found, because we don't have any development environments as of now. So don't worry about this, but this is a very important feature. And if you are admin, and most of the time what happens is they bypass these laws. So if you want to ensure that the administrator also cannot bypass these branch protections, then you can just select this. Now let's go back to the code, and as we have some changes from develop branch, so what I can do is I can come here and I can give the message the pull request message, and I can just add some comment. Please review the change. This is a new change, and some message that you want to give along with the information that you have. Like mostly what we do is we give test cases, we point to the Jira ticket that we are working on, or what exactly has been made in this particular change. So you can do these things, or you can attach files as well. So it's something that depends on you. It's a very good thing. Then just click on create pull request. Okay. Continuous integration has not been set up, so it is not going to catch any bugs or anything. Don't worry. And this change is for master from develop. Okay. So when we created the change, we created it so that we can merge changes from develop to master. Let's see what are the changes. So the commits basically is this particular ID. So if you go back and see git log, this is the change from develop BAEDE. BAEDE. This is the commit. That is what it is showing right now. Files changed is this. This is the change that we had made. So we have reviewed that. Okay, this change looks good. We'll come back here. Okay, let's add some comments like, okay, this change looks good. Well done. And once it is done, you can just comment on it. And once you have added the comment, click on merge pull request, or you can see different options. You can squash the change, or you can rebase and merge depending on what the requirement is or the current status is, but we'll discuss about those features. Don't worry. For now, just click on merge pull request. Confirm merging. Okay, we are set. So if you go back to your code, now if you can see here, we have 7 commits. Sorry, we have 7 commits, and you can just click on this. So merge pull request from develop branch. Let's do a git branch. So now I am in develop, git checkout master. So I have switched to master, and I'll do git status. On branch master, your branch is up to date and nothing to commit, working clean. I'll do a git pull to pull the latest changes because I don't have. So now if you see, if I go back, I have Pythoholic website progress. And let's see what the change we had here. Pythoholic develop branch code. So our changes have not yet synced to the local yet. So even though I am in the master branch locally, but I don't have the current code or the latest code. So this is Pythoholic develop branch code, and this is in master, isn't it? We are in master right now. The remote has some changes that we don't have. So let's pull the changes. See, now it has pulled the changes. So this is the latest change that I have right now. Let's go back to Visual Studio Code. See, now we have the latest changes. So these are some things that are really important because we just keep on making changes, and ultimately, we end up in a situation where we actually do merge conflicts. So make sure that you have your latest code available to you, or when you're working, always try to pull your code before making any changes. So that's a very good habit. Otherwise, what you have to do is you have to stash your change, pull your change, then actually again, make changes to the current code. We'll do a git status here. So we are on master, and let's see if we can make changes to this directly. We had a rule protection, master branch. Okay. Git status. Let's do a commit. Git commit -am and master branch change. I'll add the commit message. Git commit -am commit message. Just hit enter, and let's do a git push, and let's see. But we had that branch protection rule. So what do you think? Will it be pushed or will it be not? Or will it throw some error? Let's see. Oh, it worked, isn't it? It is pushed. It did not throw any errors. But what about the branch protection rule? Yes, let's go back to that. If you click on settings again, on branch, and if you edit this protection rule, what happened here is there is a setting called do not allow bypassing the above settings. And the above setting will apply to administrators and to custom rules with the bypass branch protections permission. So I have bypass branch protection permissions because I am the administrator. And when I select this, that privilege from me will be taken away. Let's go back. Let's save the changes here. And let's go back and let's make another change. Git master, new change. Let's repeat the process again. Let's do a git status, git diff. Okay, so this is the old change, this is the new change. Then we'll do a git commit -am. New changes again to master. Git push. Let's see if this time it is allowing us to push the change or merge the changes without a pull request. This is the beauty of having control, access control. Remote resolving delta completed with 2 local objects. Protected branch update failed. Changes must be made through a pull request. So changes must be made through a pull request. That's the rule. Remote rejected. But in this scenario, we have changes in the master, right? What can we do? Now, what can we do now? So most importantly, what we have to do is we have to just see git status. So your branch is ahead of origin master by 1 commit, but we can't push changes because we have a rule in place. So for that, what we can do is we can check out to develop git branch. So now I'm in develop and I'll do a git merge from master. Okay, so I have made a git merge from master. So I have taken the changes from master. Now what I will do is I'll do a git push. Yes, fine. It is fine for me to push it from develop branch because there is no rule set in the develop branch. So even though I had made a mistake of committing the changes or writing the changes without even noticing that I was working on the master branch, the branch protection rule actually helped me to avoid any unnecessary pushes or commits to that branch, or what do you say, directly from any local repository. So I have 2 branches now. I'll go back to develop, and this branch is 1 commit ahead of master. It's fine. I know that. Let's go to pull requests here. Click on pull request. Create new pull request. Click on this. Compare base is master. Compare with develop. So discuss and review the changes in this comparison with others. So you can just create a pull request. So this is a new change that I wanted to have in our master branch. There are split views as well. Like if I do a split view, so it will show me in this way as well. Like this is a very good way. I like this way actually. I can see both the sides, what exactly has been changed. Unified is also fine, but it depends on you. Now I can just create a pull request so that I can merge the changes that I have made in the develop branch. So I'll just create a pull request now, and I'll just click on create pull request. As you can see, the branch has no conflict with the base branch. Merging can be performed automatically. Okay, that is very good. Now what I can do, I can just merge the pull request, and I can confirm merge, and I can just merge it. So the changes are merged. Go to code, master branch, go to the commits. So another change, merge pull request from this. So I have merged it, and it is verified as well. Let's go back to the local repository. Let's check out to master. And now what happens is, if you do a git status or a git log, the current change it will show is this one itself, new changes again to master. So what I want to do is, if you do a git pull, it will track the history as well. What are the changes that have been made? So let's do a git pull. Okay, so it has done the git pull and it has updated the history and the revisions. So if I do a git log again, it'll keep it clean. So that is why it has now the message added to itself, like merge pull request to from Pythoholic demo /develop. If we go back here, you can see that change was not there. That historical change was not there. So I hope you got an understanding of what exactly we are trying to do. There are a lot of options for us, or a lot of features that we can discuss, and we will discuss in time to come. But I hope you got an idea of how we can get started with Git, how we can actually communicate with a remote repository, how we can actually make changes, how we can add the changes, how we can commit the changes, how we can push the changes, how we can actually pull the changes, how to create a pull request, how to provide a branch protection rule, and how to avoid mistakes. So that was the whole point of the demo, to get you started with simple things so that we can move on to more complicated things in the future. So make sure that you do these small demos and hands-on demos for your practice as well, so that whenever you want to perform any operations or you want to use them in real time, you can basically use them with confidence. So that's a very good thing.